Right, before I make a start on the C grade questions, I need to go back to the first question because it's occurred to me when I was going through and checking my work that I made a mistake here. There's no way 8 lots of £3.75 is going to come to £11.75, so something went wrong there because 8 lots of 3 are 24 if they were £3 a pack. So I need to go and make my changes here, and let's go and check 8 lots of £3.75 30. So that should be £30, which then means that this answer is wrong too. It should be 32 plus £38.10 plus 30 plus £51.98, which is £169.40. Which means that isn't that, it's that, which means times 0.05 comes to £8.47. So didn't have a good start really, did I? I made a few mistakes in that paper. There we are, we're all human. Okay, so we're on to the grade C questions now. And the first one is a domestic bill, and it's slightly different to electricity. This time we're looking at water. So let's see how it's being charged. So Value Water Company measures the water used by a household in cubic meters. There's a quarterly standing charge of £7.45. So you've got to pay that whether you use any water or not. The first 25 cubic meters of water are charged at a rate of 93 pence per cubic meter. So that's in pence. First job is going to be to change that into pounds. All further water used is charged at a rate of 132 pence. Again, we're going to change that into pounds per cubic meter. Calculate the quarterly water bill for a household using 46 cubic meters. Okay, so that's how much water is being used. Some of that, the first 25 cubic meters, are charged at this rate. So the cost of the first 25 cubic meters will be 25 times 93 pence, turn it into pounds, 0.93. £23.25. Then every extra cubic meter used is charged at 132 pence. So our extra is going to be 46 less 25. So there's another 21 cubic meters remaining. 21 cubic meters. So that plus that is 46. 132 pence, £1.32. So we do 21 times £1.32, 27.72. So the total cost for the water that she's used, or the house has used, is the sum of those two. But then on top of that, we've got the quarterly standing charge, which you'll have to pay regardless of how much or how little water you use, is £7.45. So the total bill will be £23.25 plus £27.72 plus £7.45. £58.42. So there's 6 marks for that question. You can see how that's going to break down. You're going to have 2 marks for working out the cost of the first 25, 2 marks for the remainder, and 2 marks for getting the total bill. A different water company, Trevi Water, has a different scale of charges. This one has got a standing charge of £4, a different starting volume and cost, and a different remainder. Write down in its simplest form an expression for the quarterly bill in pounds for a water customer who uses X cubic meters. Okay, so we're well into the C zone now because we're introducing algebra. So let's see if we can go through the same process that we did up there, but with this X. So the first 10 cubic meters is going to cost £1.50. Will be 10 lots of £1.50, which is £15. The next amount of water is going to be paid at £2 per cubic meter. Now, if we were using the 46 cubic meters as we were up here, what you would be doing is doing the 46, take away that, and then that's by the higher charge. So for the remaining water is going to be X less 10. That's the remaining volume of water. However much they've used, take off the 10 is X minus 10. So the cost of the remaining water is going to be X minus 10 times 2. Okay, that's how much remaining water is going to be charged at this times 2. Now that is the same as writing 2 bracket X take 10, because when you times something it doesn't matter the order, and we can simplify that to 2x, 2 times x, and then 2 times negative 10 is negative 20. So the cost of the remaining water is 2x take £20. So the total bill is going to be 2x take 20, the cost of the remaining water, plus the £15 for the first 10 cubic meters, plus the £4 standing charge. So if we simplify that as much as we can, there's no other x terms, so it's only 2x, but what we've got here is negative 20, and then we're going up 19 places, up 15, and then up another 4, so we end up at negative 1. So in algebra, in its simplest form, what they're looking for is 2x take 1. So you're going to get 1 mark for the £15. You're going to get a method mark and an answer mark for getting to either the 2 bracket x minus 10 or the 2x minus 20, and then you're going to get a final mark for adding them all together and getting it as simple as possible. So that is a nasty bit of question. That's the toughest 4 marks on the paper so far. Total for the page 13. So there's a lot of marks. There's 10 marks for that question. And there's more. Mr. and Mrs. Alston recycled the water from their bath and washing machine to use in their garden. Their meter reading in cubic meters on the 1st of April was 1678, and on the 13th of June it was 1702. They recycled 8 cubic meters of water used between April and June. Find the percentage of the water that they recycled. Okay, so the number of cubic meters used is the difference between those two. So cubic meters used is going to be 1702 take 1678. and of those, 8 of them didn't go down the drain. 8 of them were recycled. So the percentage that they recycled is, out of the 24 cubic meters that they used, 8 of those were recycled. So to turn into a percentage, you times it by 100. So fraction button, 8 over 24 times 100 equals 33.3%. Okay, so for that, 1 mark for working out the units used, 1 mark for the method, 1 mark for the answer. Okay, so now we've got a scatter graph to draw. So the first thing to do is to look at your scale to work out how many each little square is worth. So we're going from 0 to 20 in 10 squares. So each square must be 20 divided by 10, 2. So it's going 2, 4, 6, 8, 10, and so on. And on this scale, it's exactly the same. So once we know that, we're in business. So we plot a point that goes like that. So 26 is its age, and it goes up to 100. So 20, there's 100, 2, 4, 6. Mark across clearly. 40 against 60, 40, 60, and again with a scatter graph, if you make sure you mark to know that you've plotted each point. 70, 80, 60, 70, 80 is there. 50, 70, 50, 70, 46, 50, 50 is there. 46 will be 2, 4, 6 there. 80, 40 is there. 66, 20, 2, 4, 6 is there. 64, 50 is there. 70, 50 is there, and 32, 30, 30, 32, 30 is there. Write down the age and price of the oldest chair. So the oldest chair will be the furthest along this axis, so it's that one, which is 80, and its price is 40. Does the scatter diagram indicate that there is correlation between age and price of chairs? You must give a reason for your answer. So it doesn't show any correlation. Because in order to do so, as one of these goes up, so must the other, or as one of them goes up, the other must come down. So basically you want the crosses to be lying in a straight line. But probably the easiest thing to do is to say no correlation if there was, points would form along roughly a straight line. And then you could show an example. That would be going up. That would be going down. So you're giving all the information that you're understanding why there's no correlation there. So 2 marks for the plotting, 2 marks for the values, and 1 explanation mark. So 3, 6 for the page. A leather sofa costs £2,400. Each year the value of the furniture depreciates by 18% of its value at the start of the year. At the end of 2 years, by how much is the value of the leather sofa depreciated? Okay, so the easiest way to remember how to do this is to do it in a repetitive way. So if we find out what 18% of that is, that's how much it loses in the first year. So loss in year 1 would be 0.18, 18% written as if it was in pounds, pence written in pounds, times 2,400, £432. So at the end of year 1, it's lost that much value. So value at end of year 1 would be 2,400 less 432. So 2,400 less 432 is 1968. Over the second year, it's going to lose now 18% of that. So it's now not losing 18% of its original value because it's not worth that much anymore. So it's going to be 18% of so it loses in its second year £354.24. So value at end of year 2 would be 1968 less 354.24. So it's worth £1613.76. So that's not the quickest method of doing that, and if we were on the higher tier I'd do it a different way, but for the foundation tier that's probably the easiest way of following it. So 2 marks for finding the value at the end of the first year, 2 marks for going on to find the value in the second year. Question 18, you get a right-angled triangle, and in the foundation paper, if you know 2 sides and you want to find a third side, it's going to be Pythagoras. You don't have to worry about trigonometry or anything else. The first thing to do is square the sides that you know, and you can do that on the triangle. So you've got 9.2 and the squared button is there, 84.64. You square the other one, you get 70.56. And this is the side that we want to find. So that's the first job, square the sides that you're given. Then the only thing you have to decide is, in order to find the other side, are you going to add these or subtract them? So the decision that you have to make is, are you trying to find the longest side, hypotenuse, or are you trying to find one of the shorter ones? You can see here you're trying to find one of the shorter ones. If it's a shorter one, you subtract your squares. If it was the hypotenuse, the longest side, you'd add the squares. So the next thing that we're going to write is 84.64 take away 70.56. (14.08). So we haven't had to worry about a squares equals b squares plus c squares. You don't need to worry about that. You square everything you see, which is a number. You decide you're going to add them or subtract them. If you're trying to find the shorter side, you take them away. If you're trying to find the longer side, it's going to be bigger, you need to add them together. And then to find the missing side, we've got to undo squares. So the opposite of squaring is square rooting. So x is going to be the square root, that's the symbol for square root, of 14.08. Square root button is there, 14.08, 3.75 to 2 decimal places. It hasn't asked you to give it for any particular number of decimal places, so that will be fine. 1 mark for squaring, 1 mark for subtracting, 1 mark for getting your answer. And then the final question is a bit of a beast because it's a pile of information, and what you've got to hope is that on the foundation tier it's the last question, it's worth 4 marks, and you aren't relying on it to get a grade C. So long as you've picked up loads of marks on the easy questions, this won't be a problem, but let's take a quick look at it anyway. So concrete blocks in the shape of cuboids, so the concrete blocks look like that. Oops, that wasn't very good, was it? It didn't fit on the page. So you got your cubic concrete blocks made using cement, sharp sand, gravel and water. A builder's yard offers customers use of their concrete quantity calculator. Customers enter the length, width and depth, so they put the length, width and depth of the block of concrete they want to make. The calculator then works out the quantities of cement, sand and gravel and water needed. One customer enters her measurements, length 0.5, width 0.2 and depth 0.3 for the concrete she wants to make. This is what the concrete quantity calculator shows. So she's put in 0.5, 0.2, 0.3, and what the calculator then does is say you need to buy 10 kilograms of cement, 18 kilograms of sand, 36 kilograms of gravel, and you need to use 5 litres of water. We now have to work out what it's going to be for a block which has got different dimensions. And what we have to do in order to do that is to work out what the scale factor is between this block and that block. And in order to do that, you need to work out the volume of the 2 blocks. So volume of first block, and the way you work out the volume of a cuboid is length times width times height or depth. So it's going to be 0.5 times 0.2 times 0.3. So that's 0.03 cubic meters. So that's how much stuff would pour into that block to make that volume. So now we want to work out the volume of this second block. Which is 0.6 times 0.4 times 0.2. So different dimensions, different volume. Oops, lost control of the calculator. 0.6, 0.4, 0.2. 0.048 cubic meters. So what we need to do now is to work out how many times bigger this block is compared to that, and then it would work just like if you were scaling up a recipe for a cake or bread or something like that. We know how many times we've got to multiply these by to get these. So scale factor would be 0.048 divided by 0.03. .6. So the second block is 1.6 times bigger than the first block. So that means that we have to take every quantity in the first one and multiply it by 1.6. So sharp sand is going to be 18 times 1.6. $28.8. So that's going to be 28.8. Then we're going to do 36 times 1.6. 57.6. And finally 5 times 1.6. 8. So there are going to be everything is going to be 1.6 times bigger, so it's going to be that times 1.6, that times 1.6, that times 1.6. So you're going to get 2 marks for working out the scale factor, and then 2 marks for working out the different values. Total for the page 4, 8, 11. And that's it. That's the last question.